Today we're learning about simplifying radicals, but first you have to know what a radical expression is. It's an expression that's written using a radical sign, and it has two numbers, n and it's root a. For this class, we'll be mostly working with the square root of a, which the little 2 means its square root, but it's commonly written like this without the little 2 as the index. So the first part says find all of the factor pairs for each number below, and then circle the factors that are perfect squares. So we need to find all the multiples of 12. So the numbers that make 12 are 1 and 12, remember we're multiplying, are 2 and 6, and are 3 times 4. So out of these, are any of these perfect squares? Well, a perfect square would be 4. Okay, let's go to 125. Well, 125 is going to be 5 times something. Do you know what that is? It's 5 times 25. So 5 times 25, we obviously know it's 1 and 125, but nothing else is going to make that one. So in this case, we're going to use the 25 because that's a perfect square. Okay, let's go to 24 now. So 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So out of all of these numbers, there's one perfect square, which is a 4. Okay, let's go down. It says to simplify a radical, easiest way is to look for the largest perfect square roots, but this is not the only way. So 12, are there any perfect square factors in 12? Yes, we found it above. So for this, the perfect square factor is 4. So it says break down into the two factors. That includes the largest perfect square you can find. So the largest perfect square for 12 was 4, so that's 3 times 4. And when you do this, 4 is a perfect square, so it breaks down as 2 times 2. And when you're doing these, you are pairing them up. So I have a pair of 2's, and then I have a single 3. So this square root of 12 is going to break down to 2 square root of 3. So that's the step we just did. Couples go out, singles stay in. So the simplified radical expression for the square root of 12 is 2 square root of 3. Now let's try some below. So a lot of times I like to start with 2, but 2 doesn't go into every number, like 75. 75 ends in a 5, so I know a 5 is going to go into it. I also know a 3 is going to go into it, because if you think about 75 cents, that's 3/4. But let's use 5. So 5 times what number? 5, 10, 15, 20, 25, 30, 30, 40, 45, 50, 55, 60, 65, 70, 75, 15. And literally all I was doing was just counting on my fingers. This whole section is no calculator unless you have one of the little just 4-way simple calculators that you can get from Dollar Tree. Okay, so they look like this. So you're allowed to use one of these for this section, but that's it. That's just to help you make your factor tree if you're not good with your multiples. Okay, so 5 can't break down anymore because it's prime. It just means 1 times 5, and for these, we don't care about 1. So 15 is going to be 5 times 3, and 5 and 3 are prime. So we are done with our factor tree. So now we're going to look at all of the numbers in the bottom of the tree. So again, you have to find pairs. That's a set of 2 numbers. So here we have a pair of 5s, and then we have a single of a 3. The pairs are going to go out, and the single stays under the house, stays under the radical. So the radical is going to have a 3 on the inside, and this pair of 5s goes out as 1 5. So 5 square root of 3 is the square root of 75. Okay, now let's try 2. So it's 8 square root of 24. We're going to ignore the 8 for now, and then we're going to deal with him later. So let's just do the square root of 24. So this one works. It's an even number, so I can have 2 go into it. So 2 times what number makes 24? 12. 2, again, cannot break down anymore. 12 can, though. 12 is 2 times 6. Okay, 2 can't break down, but 6 can. 6 is 2 times 3. Now we're at 2 and 3, so those can't break down anymore. So again, we're looking at everything on the ends that's done breaking down. So in this case, we have a 2, a 2, a 2, and a 3. So out of these, I can make one pair of 2s. And this 2, though, and this 3, they're both singles. They don't have another number to match with them. So we're going to have this 2 come outside, and we're going to have the square root of 2 times 3 inside, because those were the singles. But 2 times 3 is 6, so we're going to make it 2 square root of 6. But remember in the beginning how we said we're going to leave the 8? We still have to deal with this 8. This 8 has to come down, and it's going to go out in front. But when two numbers sit next to each other, they're multiplying. So it's not 82, it's 8 times 2. So your final answer is going to be 16 root 6. 16 square root of 6. Okay, go ahead and pause this video and see if you can make the factor tree for number 3. Okay, you should have paused this video to see if you can make the factor tree for number 3, and this is how your factor tree should go. 125, 5 can go into it again because it ends in a 5. And if you're not sure 5 times what, turn on your calculator and do 125 divided by 5, and that'll tell you what multiplies. So it's 25. And if you're still not sure if you're right, go back and do 5 times 25, and it gives you 125. So that's how you know you're correct. So then 5 can't break down, but 25 can. 5 times 5. So again, we're looking at all the ones at the edge. So in this case, we have a pair of 5s and a single 5. So your final answer should be 5 square root of 5. This is the 5 from the pair, and this is the 5 from the single. Okay, let's go to number 8. So number 8 is 6 square root of 81. So again, we're going to leave the 6 till the end. I'm just going to circle him in purple so we don't forget about him. And then the square root of 81. You can make a factor tree for the square root of 81, but the square root of 81 is a perfect square. So if it's a perfect square, that means that the square root of 81 is already 9. So you have to bring your 6 down though. And it's not a 669, it's a 6 times 9. So 6 times 9 should give you a 54. So in number 8, there's no roots left because the square root of 81 is a perfect square. Okay, the special snowflake, notice how everything we've done does not have a negative underneath. This guy you're going to deal with in Algebra 2. That's why he's a special snowflake. Algebra 2. And the negative, though, we can't do right now. They're called imaginary numbers. So technically, this answer is going to be 3i, which you don't have to know right now. You're going to learn more about this in Algebra 2. Just wanted to make sure you know that you cannot do it with a negative underneath. We haven't learned that yet. Okay, so now it says let's add some variables. So we're going to do it the same way, and we're going to ignore the little square root of x squared till later. But let's just do the 75 first. So 75, we did on the other side as 5 times 15. This time, though, I'm going to do 3 and 25 because it makes me think of money. So 3 times 25, 3 can't break down, but 25 can. So 5 times 5. So now again, we're left with all the ones that can't break down anymore, 3, 5, and 5. Again, you have to make your pairs. Pairs go out, singles stay in. 5 square root of 3. However, that's the answer if it was just the square root of 75. But there's an x squared on it, but it's okay. We can do that the same exact way. X squared is the same thing as saying x times x. So again, we're looking for pairs. So I have a pair right here. There are 2 x's, which makes a pair. So again, pairs go on the outside. So this pair of x's is going to go on the outside with the 5. Well, we're not going to write x5. We're going to write 5x square root of 3. Okay, let's go ahead and try number 4. So again, there's a number on the outside. Don't forget about that. We're going to leave that till the end. So let's do the square root of 28 and then the x cubed. So 28 is 2 times 14. 14 is 2 times 7. So out of all of our numbers on the outsides, on the bottom of the trees, I should have a pair of 2s. And then a single 7. Okay, now for x cubed is how many x's? Not just 2 this time, it's 3. So out of 3 x's, you can make a pair and have a single. So we're going to take the 2 and the x and put it on the outside of the root. So there's our root, there's our house. 2x is going to go on the outside. And think about what you're putting on the inside. You then on the inside are putting a 7 and an x. So 7x, because remember you're multiplying. But that's not our final answer, because remember we circled this 2 up here. So you have to bring this 2 down here. And remember, it's not going to be 22. What's this going to turn into? Should turn into a 4. So we have 4x square root of 7x. I want you to go ahead and pause this video and try number 5. You should have tried number 5 by now, and this is somewhat of what you should have gotten. When you broke it down for 8, you should have had 3 2s. So you have a pair of 2s that comes out as 1. You have a single 2, which stays in. And then your x's, there's 6 x's, which ends up making 3 x's when they come out. And then that negative 3 had to come down to the front. However, we can simplify this sum so it doesn't look so ugly. So negative 3 times 2 is going to be a negative 6. If I have 3 x's that are multiplied by each other, that's going to be an x with a power of 3 and then a square root of 2. So what do you notice when you have an x squared or an x to the 6th when the power is even? How do you go from the x squared to the x, or from the x to the 6th to the x cubed? You should notice that when it's an even exponent, if you divide by 2, you get x cubed. So here, x squared, 2 divided by 2 gives you a 1. 6 divided by 2 gives you a 3. Up here on number 3, it's an x to the 4. So x to the 4 divided by 2 is going to give you an x squared on the outside. The only difference if it's odd is you have one guy left over. So you take one off and then divide by 2.